Okay, hello everyone. Want to have a crash course on modular arithmetic. So let me share my screen with you. Okay, so this is the question that I gave you in your holiday assignment. Question number 1. It says construct a table for multiplication in modulo 7 on the set 2, 3, 5, 6, and then use the table to solve the following equations. If you were not given this set, then you will have used the digits 0 to 6. Okay, but see, we are given a set. You use a set given to you 2, 3, 5, 6. So I'm going to teach you how to solve this kind of a problem now by us looking at what I have here. Okay, so this question says draw tables for addition and multiplication. The first thing I want to take note of that we have special symbols that we use in modulo. What we call addition in normal arithmetic is written this way in modulo. So anytime you see something like this, maybe they say 5 plus 4, you know you are doing modular arithmetic. It's different from our normal 5 plus 4. This one gives us 9. But this one, you need to know the modulus in which this is happening. So we have subtraction, we have multiplication, and of course we have the division symbol. So these are the 4 operators that we use in modulo. Okay, now how do you do modulo? How do you solve problems on modulo? It's very simple. If I ask you what is the value of 12 in modulo, let's say modulo 5, okay, what you simply do is to pick the 12 and divide it by 5. When you divide 12 by 5, what do you get? You get 2 remainder 2. Okay, 5 times 2 is 10. 10 plus the remainder 2, that gives you 12. It is this remainder that we're actually interested in under modular arithmetic. Okay, so in answer to the question, what is 12 in, I'm going to shorten this now to mode 5. That's the way you would normally shorten it. What is 12 in mode 5? You simply say the 12 in mode 5 is 2. Remember, all we care about is the remainder. Okay, let's look at another example on this. What if I say, what is, let's say, 7 in modulo 2? Again, you pick up the 7 and you divide it by 2. We divide it by the modulus. Okay, and 7 divided by 2 is 3. Remainder 1. So that means the answer to the question, what is 7 in modulo 2, is just 1. Okay, like I said earlier, all we care about under modulus is just the remainder. Okay, when we treat the topic, I will explain to you why the remainder is what we are really after. But for now, I'm just trying to explain how to solve the holiday assignment. Okay, so under modulus, modulus has some similarities with number base, because under number base, in base 2, for example, you use the digits 0 and 1. The same thing here in modulo 2, which is the simplest modulo you can have. There's no such thing as modulo 1. The digits that you have here are 0 and 1. In modulo 3, the digits you use here are 0, 1, and 2. In modulo 4, you use 0, 1, 2, 3, and so on and so forth. So that means a modulo, what somebody asked me, what is 4 in modulo 4, for example? Since I say in modulo 4, you can only have these digits 0, 1, 2, 3. But what if somebody asks me, what is 4 in modulo 4? The answer is always 0. And how do we show that it's 0? Simple. Do it the way we did the earlier one. Divide 4 by the modulus, which is 4. What do you get? You get 1. And what is the remainder? The remainder is 0. Okay? So that means 2 in modulo 2 is 0. 3 in modulo 3 is 0. 4 in modulo 4 is 0. 5 in modulo 5 is 0. 12 in modulo 12 is 0. And so on and so forth. Okay? Now let's look at the question now. properly. Later, we're going to look at how to deal with multiplication, subtraction, and division. But for now, let's just try and solve this question. Now, it says draw tables for addition in modulo 9 on the set 1, 3, 5, 7. We're actually given a set here. If you're not given a set, that means my table will have covered digits from 0, 1, 2. In other words, this table that you are seeing here, I will have had 0, 1, 2, 3, 4, 5, 6, 7, 8. Remember, I have to stop at 8. In modulo 9, you can only stop. You only have digits 0 to 8. So I can't put 9 there. So this will have been 4, 5, 6, 7, and 8. And then I will have had to do the same thing below. Some people actually leave out the 0. I have to do 0, 1, 2 until I get to 8. And since I'm doing addition, then I have to put this symbol here to show anybody that's looking at my table that this is modulo addition. Okay, so you can see the tables I've drawn below. The one above is for addition, while the one below it is for multiplication. And then they said we should do it on the set 1, 3, 5, 7. So that means I'm going to come here and write out the sets 1, 3, 5, and 7. Here also I'm going to have 1, 3, 5, 7. Here I'm going to have 1, 3, 5, 7. Here also 1, 3, 5, and 7. Okay, now we're going to fill up the cells. Now what you are going to put here is what you will get for 1 plus 1. Okay, this one will be filled up with what you get for 1 plus 3. This one for 1 plus 5. This box here will be filled up with what you get for 5 plus 5. This one here will be filled up with what you get for 5 times 3 in modulo 9. Remember, since we're working in modulo 9, the only digits you can get for this whole operation will be digits from 0 to 8, because we are working in modulo 9. Okay, if you have anything that is more than that, then you have to use the division symbol. Anyway, we're going to look at that later. Anyway, so let's start now. Let's clean up these cells first. Okay, let's start with the first one. We want to fill the first one, 1 plus 1. What is 1 plus 1 in modulo 9? 1 plus 9 is 2. Remember that the digits 2 exist in modulo 9. It's only digits that are 9, 10, and above that don't exist. I'm going to put 2 here. The next one is 1 plus 3, which is 4, which of course exists. So the next one is 1 plus 5, that's 6. 1 plus 7, that's 8. 8 exists. So the next one will be 3 plus 1, which is 4. 3 plus 3, which is 6. 3 plus 5, which is 8. And then the last one, 3 plus 7, which is 10. I cannot write 10 here, okay? Because I can only use digit 0 to 8. So 10, I'm going to divide 10 by the modulus, which is 9. And 10 divided by 9 is 1, remainder 1. So that means I'm going to have 1 here, okay? Then 5 plus 1 is 6. 5 plus 3 is 8. 5 plus 5 is 10. The same thing, of course, I'm going to get 1 here. 5 plus 7 is 12. 12, what is 12 divided by 9? That is 1, remainder 3. So I'm going to have 3 here. Like I said earlier, you can see all the digits here are between 0 and 8. Then 7 plus 1 is 8. 7 plus 3 is 10. We did 3 plus 7 before we got to 1, so this is also going to be 1. 7 plus 5 is 12. We did 5 plus 7, we got 3, so this will also be 3. And lastly, 7 plus 7 is 14. 14 divided by 9 equals to 1, remainder 5. So the first table is already filled up for addition. Very simple. Now let's look at the second table, which is for multiplication. 1 times 1. 1 times 1 is 1, and 1 exists in modulo 9. 1 times 3 is 3. 1 times 5 is 5. 1 times 7 is 7. 3 times 1 is 3. 3 times 3 is 9. 9 in modulo 9 is 0. But let me show it again in case you've forgotten. That will be 9 divided by the modulus, which is 9, which is 1. Remainder 0. So this is 0. 3 times 5 is 15. 15 over 9 is 1. Remainder 6. So this will be 6. 3 times 7 is 21. 21 divided by 9 is 2. That's 18. 19, 20, 21. So that's remainder 3. So this will be 3 here. 5 times 1 is 5. 5 times 3 is 15. 15 divided by 9 is 1, remainder 6. 5 times 5 is 25. 25 over 9. How many 9s can we get here? That's 3. No, sorry, that's 2. 9 times 2 is 18. Remainder 7. So this is 7. 5 times 7 is 35. Let me clean up this our rough work here. 35. So 35 divided by 9. How many 9s can we get in 35? 9 times 4 is 32. So that is 4. Remainder 3. So the answer to this is 3. Okay, now let's look at the last row for the multiplication table. Okay, 7 times 1 is 7. 7 times 3 is 21. I think we've done 3 times 7 before. We got 3, so this should also give us 3. 7 times 5. We've done 5 times 7. We got 3, so this also will be 3. And lastly, 7 times 7, 49. So what is 49 divided by 9? How many 9s can we get? And 9 times 5 is 45. So that's 45 remainder of 4. So the answer here is 4. So the two tables are completely filled. The next thing we're going to do now is to use the table, because normally the question will say use the tables. When the question says use the tables, that means you have to use the tables. You must not go outside the table in solving a question. Okay, now let's look at the first question. It says find the truth set of n star 5 plus n star 3 equals to 6. Now you see that they're asking us to find the value of the letter n. Is n has to be one of the numbers 1, 3, 5, or 7. So the easiest way to solve this problem is just to pick the numbers one by one, put them into the equation and see whether the left-hand side here, will be equal to the right-hand side here, which is 6. Another way is to look at the ones that give you 6. But that one will be a tough method. I would advise that you just use the digits. So I'm going to start with 1. Remember, we have digits 1, 3, 5, 7. So I'm going to put 1 here all over the place. Another one, I'm going to put 1 here. This is going to become 1 times 5, BODMAS, then have plus, then I'm going to have here 1 times 3. I'm going to see whether this is going to give me 6. But please, if you discover that the value of n equals to 1, that does not mean that you are done. Sometimes n may be more than one of the elements. N may be 1 and 3 or 1 and 5 or even all of them. So you have to test for all of them before you safely conclude. So that means since I'm saying n equals to 1, like I said earlier, like I've written up there, let me write it clearly here. I want to check 1 times 5 plus 1 times 3. I want to see whether this will give me 6. So I have to go to the table. What is 1 times 5 from the table? 1 times 5 from the table is 5. So the whole of this is going to give me 5. Then I have plus, the plus sign in between them. Then I now have 1 times 3. 1 times 3 is 3. So then I have 3 here. Okay, then so I've used the table for multiplication to get this. Now I have to go to the one for addition, because you can see the addition sign between 5 plus 3. What is 5 plus 3? 5 plus 3 is 8. So I'm not getting 6. So that means n is definitely not equals to 1. Okay. So I have to cancel 1 out of the options. I have to go and pick the next letter, which is, the next element, which is 3. So let me plug in 3 and see what happens. If I put in 3, let me use this other more fashionable symbol for my bracket. Let me put in 3. So 3 times 5 plus 3 times 3. So let's see whether this will give me 6. Now what is 3 times 5 from the multiplication table? From the multiplication table, 3 times 5 is 6. Your table has to be accurate, otherwise you are going to make mistakes. You'll be reading the wrong value from your table if your table is not correct. Then 3 times 3. 3 times 3 is 0. 3 times 3 is 0. Now what is 6 plus 0? 6 plus 0 equals to 6. Okay, 6 plus 0 equals to 6. So that means n equals to 6. As you can see, I was able to get 6 that I have here on the right hand side. Okay, so we have a value for n, 6. But let's move on and test the other elements. We need to test for 5, and then we need to also test for 7. So let me put in 5 here and see what happens. If I put in 5, I'm going to have 5 times 5 and then 5 times 3 here. Now what is 5 times 5 from the table? From the table, 5 times 5 is 7. And then 5 times 3 is 6. Okay. Now 7 plus 6. Now I have 7 here in the addition side, but there is no 6 there. So that automatically cancels this option. So don't go ahead and don't go outside the table to do 7 plus 6 because there is no 6 there. Okay, if you go outside the table, you're going to have 7 plus 6 is 13. 13 divided by 9, and that will be 1 remainder 4. And if we're not even getting the answer anyway, so but don't go outside the table. Each of them must contain the correct answer. So 5 is not one of the answers. Let's check for the last one, 7. If I'm using 7, I'm going to have 7 times 5 here plus 7 times 3. Okay, let's see what this will give us. 6. What's 7 times 5? 7 times 5 from the table is 3. So I got 3 here. Plus, what is 7 times 3? 7 times 3 is 3. So I have 3 plus 3. 3 plus 3, I can see 3 plus 3. There's no, okay, 3 plus 3 from the table is 6, as you can see. 3 plus 3 from the table is 6. So that means n equals to, we said n equals to 1 is a solution. I think that's what we said. No, or what did we say? I think we said n equals to 3 is n equals to 3 is a solution, and now we have also seen that n equals to 7 is also a solution. Okay, so these are the two solutions to this to the first part of the question. So how do you write the answer? Because it says find the truth set. So this is actually the way you write it. I will explain to you later why you write it this way, but for now, just take it from me. You will say this set n such that n equals to 3 and 7. Okay, so this is how you write your answer when you have to find the truth set. Okay, so that is question number 1. So I'm going to leave the other ones for you. For the other one, for question number 2 now, n has to be, of course, n again has to be either 1 or 3 or 5 or 7. If you plug in, you do what is inside the bracket first, do n star n. For example, if you put n equals to 1, you first do 1 times 1. 1 times 1 gives 1, so the whole of this becomes 1. Then you now have plus 1. Now what is 1 plus 1 from the 1 plus 1 from the table is 2. So that means n is not equals to 1 because 1 did not work. Then you try for 3, try for 5, try for 7 until you get your answer to be 3. So this is the way you're going to solve the problem. I want to also ask you to also do B as a practice so that you can get better at this. But when we look at this topic properly in class, I'm going to explain it to you more thoroughly what modular arithmetic or modulo arithmetic is all about. So thank you very much. See you around.